Welcome to this section of this course. I will be speaking today Wallis Theorem. Is applicable when integral of this from 0 to pi by 2 of sine of any indices as well as cos of any indices of x. Here we have m over here, we have n over here, okay, dx. So Wallis theorem is applicable only when the limit should be what? 0 to pi by 2, okay. If it is not 0 to pi by 2, we can bring into 0 to pi by 2. For example, minus a to a f of x dx is equals to what we have? 0 if f of x is odd, okay. And then is equals to twice 0 to a f of x if f of x is even function, okay. If it is something like minus pi by 2 pi by 2, we can bring into twice 0 to pi by 2 if fx is even. What I will do is I will take some examples. I will solve first some example. After that I will write down the statement for Wallis theorem. First I will solve some numerical. Let's see. See, if I have integral 0 to pi by 2, if I have, for example, sine of 6x and cos of 4x, how will solve this? Okay, this 6 is there, okay. So you decrease 1, okay. If I decrease 1 from 6, I will get 5. From this 5, you decrease successively 2. Okay, if I decrease from 5 to 2, then I will get 5 minus 2 is 3 and 3 minus 2 is 1, okay. Now you have to stop, either you have 2 or 1, okay. So now I have 1 here, I have to stop for this, okay. And then this is for this. How about cos? Now similarly also, if from 4 decrease 1, if I decrease from 4 1, this is component for sine, okay. Now what about cos 4 component? You decrease from 4 decrease 1, that means 3, okay. From this 3 you keep on decreasing 2, okay. 3 minus 2 is 1. You have to stop if you have term either 2 or 1. Here I have 1 here, I am stopping here also, I have 1 here, I stop over here, okay. For this denominator you add these 2, okay. You add this 6 plus 4. What is 6 plus 4? Okay, 6 plus 4 is what? I have 10, okay. So from here also same process, you decrease 2 successively, then I will get 8, 6, 4, 2, okay. Now similarly you have to stop, either you have 2 or 1. So I am having 2 here, I have to stop here, okay. Now the main part is over here, okay. Now the indices of sine as well as indices of cos, if both are even, then we have to multiply by pi by 2, okay. This is the answer, okay. Now here these are all into, you can solve very easily, okay. Now let's take another example. For example, if I have 0 to pi by 2, say sine of say 5x cos of 4x dx. Here also we have dx, okay. Now here similarly what we have to do, from this 5 decrease what? Decrease 1, okay. From 5, if I decrease 1, that's 4, okay. From 4 keep on decreasing successfully 2, okay. 4 minus 2 is 2. I have to stop here because if you get 2 or 1, I have to stop here, okay. This is the component for sin x, okay. This is component for sin x. And into, what about components for cos x? Here 4 we have to decrease what? 1 means 3, okay. Then from here also keep on decreasing, okay. Keep on decreasing, either you get 2 or 1. Here 3 minus 2 is 1. I have to stop over here, okay. And then similarly from denominator 5 plus 4 is what? 5 plus 4 is, we have 9. Keep on decreasing till you get 2 or 1, okay. 7 minus 2 is 5, okay. And then 5 minus 2 is 3, okay. 3 minus 2 is 1 over here, okay. So I have to stop here 1 because I have either 2 or 1, okay. And then What term will come? Here, if, okay, here pi by 2 comes if both m, okay, or you can say both m and n are even. Okay, both. If both are even, then pi by 2 will come, okay. Then otherwise 1 will come, okay. Otherwise 1 will come. Means here 5 is odd, 4 is even, okay. So both are not even. Therefore 1 will come here, okay. So this is the required answer for this. Let's take another example. Let's take example from 0 to pi by 2. Sine of, for example, 9x cos of 6x dx. Okay, how to solve this? Okay, by Wallis theorem is equals to, as I told you, remember, from this power 9 you decrease 1, means 9 minus 1 is 8. Okay, from this 8 you decrease 2 successively till you get either 2 or 1. Okay, so here 8 minus 2 is 6. 6 minus 2 is 4. Here 4 minus 2 is 2. I have to stop over here because I am getting 2 or 1. I am getting 2 over here. Okay, this is the component for sine. Okay, sine 9x. And then what about component for cos 6? Similarly, these indices you decrease 1 means 5. Keep on decreasing successively 2. Okay, here 5. Here 5 minus 2 3. Okay, 3 minus 2 is 1. Okay, in denominator 9 plus 6 is 15. From here you decrease 2 successively till you get either 2 or 1. Okay, here 15 minus 2 is 13. 3 minus 2 is 1. Okay, what will come over here? Whether it will come pi by 2, it will come pi by 2 or 1. Okay, see, when pi by 2 will come if both m and n are even. Okay, now here 9 is odd, 6 is even. Okay, therefore 1 will come. Okay, so if you simplify this, this is the required answer. If it is like this, for example, sine of square x dx, 0 to pi by 2. Okay, what to do this? Okay, now this can be written as 0 to pi by 2. Say for example sine 6x. Okay, sine of 6x, I can write this is same as cos of 0 into x dx. Okay, so here similarly you apply this Wallis theorem. 6, okay, decrease 1, I am having 5. Okay, and then from this you keep on decreasing successively 2, 3 minus 2 is 1. You have to stop here. Okay, now here, or you can say 6 plus 0 is 6. Okay, otherwise you can keep like this 6 over here. Similarly, you also keep decreasing successively 2 until you get 2 or 1. 6 minus 2 is 4. 4 minus 2 is 2. And then here we have to stop over here. Okay, now what will come over here? Either pi by 2 or 1. Now 6. Okay, here 0. Okay, here 0 I will consider as a even. Okay, even 0 I will consider as even. Okay, here 0, or you can say why, because 6 plus 0 is 6. Okay, even will be, what will come here? Pi by 2. Okay, you simplify this, you will get answer. Okay.